We're going to do the fundamental theorem of calculus. You know how. All right, we're going to start off with our bell work because apparently we don't remember how to do it in this class. Whoops. Huh? I don't know. Probably not very much. All right, so, guys, if I'm going from 1 to 7 with 3 intervals, how wide is each interval? 2. Thank you. So, if I'm doing midpoint Riemann sums, I'm going to do the width of 2 times, I would go, let's think about this. I'd go from like 1 to 3, then to 5, then to 7. So I want 2, 4, and 6. So my heights are f of 2 plus f of 4 plus f of 6. Nope, not allowed to say que. Guys, then say you don't understand and be specific. Don't just say que. All right. You're kind of just creating your own table, right? Going? Because you don't need to. But it's kind of. He said kind of.
Why is the x?
Then I start working those out. And I think you're smart enough to do this in your head because I gave you an easy function. So 2 squared is times 3 minus 5. Get out. 4 squared
16
times 3 minus 5.
43
Yeah. 6 squared, we're getting the big one,
36
times 3.
9
Close. 108 minus 5,
103. I did it first.
which means it's going to be 5153, which means it's 306. Look at how amazing we are. We did all that in our head. Well, I didn't, you guys told me all the answers. I just wrote them down. All right. Are you ready? Fundamental theorem of calculus. Here it is. We're going to write. We're going to write. If f of x is continuous on AB, you getting sick of writing that yet? I always am. And differentiable on AB, then where f of x is the antiderivative. That does not make sense. Then
Don't erase.
f of x is the antiderivative of f of x.
Wait, you just said that if one thing is, then the other thing also. What is the difference between
Then
f
f
of
of-
x and f of x?
What's capital F?
Don't understand. What the difference is between the capital and the other?
I said it in one of the other classes.
Yeah, but not
The antiderivative. So remember I said that often we'll use the capital to say, hey, this is the function that came before.
So the capital.
So in
comes
other
first.
words, think of it as f, like lowercase, is f prime,
Okay.
if that helps you, okay? So but the reason we're not saying that is because we could start with any function and go forward or backwards. We can take the derivative, we can take the antiderivative. Doesn't matter where we start. Does it always make sense? Not necessarily. Like if I have a position graph, does it make sense to go backwards? Probably not. I could, but it probably doesn't mean anything. Okay, so let's talk about what this is now, like when we write it out. So we're gonna go from A to B. It's easier, like the part of the reason this doesn't make sense is because I need to write it out for you. So from A to B of fx dx is gonna equal f of b minus f of a. This. Now, let's do a little caveat over here, because sometimes they'll refer to this as something else, also known as accumulated change. Now, usually when you see it written as accumulated change, it looks slightly different, and we write it as f of b equals the integral from a to b of f prime of f of x, no, f prime of x, sorry, dx plus f of a. Okay? So you will sometimes see it written like that.
F prime of X.
F prime, I mean, it's again, it doesn't matter whether you call it,
F of X.
it doesn't matter, guys, whether you call it as F prime or not. The point is that the capital one is the function that came before. So if it helps you by thinking of it as F prime, do that. If not, don't worry about it. It does not matter, it means the same thing.
That's like very weird though.
A little bit. I can wait a minute if there's not this much talking.
F of x dx plus f(a). I don't get it. I'm guessing off of like shape.
I cannot hear you because of the amount of talking you guys do.
They should take a walk. I don't know.
Miguel, don't make me a jerk, man.
Really?
Don't make me jerk.
No, I'm asking Miguel. Get out. Get out. Okay. Consider the function f of x equals negative 2x plus 3, whose graph is pictured below. Just listen. Calculate each of the following definite integrals according to the fundamental theorem of calculus. Then shade the area of the region that the integral represents. So, I'm going to go from negative 2 to 1. From here to here. Let's start by looking what that looks like. It looks like this. Now, let's go ahead and use the fundamental theorem of calculus. Okay? So, what would be the integral of this? Ladies, you're going to have no idea what's going on. So, just wait. Guys, first you need to take the antiderivative of this. So you get negative x. Hang on, man. Okay, the 2's are going to cancel because I would divide by 2 afterwards. Plus 3x. Technically plus c. And remember how I told you earlier that we were going to do something that made c go away? Screw c. Watch this. We need to evaluate this from 1 to negative 2. This function, this new function, this would be like the f of x, right? This function is like that lowercase f of x. So what this means when I evaluate it from 1 to negative 2 means f of 1 minus f of negative 2.
I don't know which f is
Capital. You got to get used to that notation.
Oh, sorry,
The College Board is going to use it a lot. No, they're not both capital. This is capital. This is lowercase.
okay.
These are both capital. Okay.
So why f of 1?
So, negative 1 squared plus 3 times 1 plus c minus negative 2 squared plus 3 times negative 2 plus c. Now, let's simplify that out a bit. This is going to be negative 1 plus 3 plus c. Negative 2 squared is 4 minus, so minus 4 minus again, oh God, plus 4.
That's a lot.
Negative 6 times negative 1, because we got to distribute this negative in, plus 6 minus c. What happened to the c's?
They cancel.
If I'm adding and subtracting the c's, they aren't going to matter. So anytime you do this, going forward, we're not going to bother writing c,
So no more C's.
because it's going to go away.
So that was just to show us that C is always gonna go away.
I'm just showing you here that like the c, when you're doing a defined integral, a definite integral, they will go away
Okay, and what would a non-defined integral be?
when there's no numbers,
Okay.
when you're just finding the equation.
So, do we have to prove this every time we do, or no?
Negative 1 plus 3, 2, plus 10, 12. Now, what you did in physics, because you didn't know calculus, you had a graph like this, and maybe it was a velocity time graph, and they said, what was the displacement? And you had to find the area under the curve
By doing a right triangle.
because you were doing calculus without realizing it. So let's do our like physics way, and let's make sure that we get 12, right? So over here, my area is going to be the width of 3 times the average of my two heights. So 1/2. This height is 7. The other height is 1. So I get 3 times 8 over 2 is 4. And I get that the area is 12. You guys love samesies. Samesies. Yep.
I don't understand, like, why f of 1 minus f of 2.
Because that's what the fundamental theorem told us to do, right? F of the top number minus f of the bottom number.
What is f of b? What is b?
Well, look at where A and B are.
Ah,
B's on the top, A's on the bottom. So f of 1 minus f of negative 2. Make sense?
perfect.
Awesome.
So, if we're asked to find this value in physics, we can integrate.
If you have the equation, yeah. All right, let's do the next one.
Emma, on the kind.
So we're going to integrate. Oh, look, it's the same thing. This time we're going to evaluate it from 5 to 2.
But if it's, can we just like, no, that is not there.
But why did you put C?
Just told us.
Yeah, because I'm not going to write it again, but it is still there here. I just don't show that.
But,
It's,
so
Still
we
there.
have to do the little line with the,
this line means evaluate it from 5 to 2. Okay, so
Is that a 3 or
it's just amazing when you told us.
negative 5 squared.
No way.
3 times 5. Okay, minus. She's driving me crazy.
Who?
You know who.
Me.
No,
Who?
Ariana.
Wait, why are you
Incomplete.
evaluating it again? Or are you not?
I'm evaluating it at 5 and 2, right? This part here is at 5. This part here is at 2, and then I have to subtract them. Camila, did you buy me a cookie?
But you didn't evaluate the, you didn't evaluate the C's.
I didn't do the C's because we know they're going to cancel. All right, negative 25 plus 15. Let's see. Negative 4 plus 6 is 2, so minus 2 in total. I'm just doing it all at once, right? What's inside the bracket? Negative 4 plus 6, that's 2, so minus 2. And so I'm going to get negative 12. What do you think negative 12 for an area means?
Under the x-axis.
Under the x-axis. That's all. Let's do it and make sure. So we're going from 2 to 5. Do you notice that that is the exact same shape as before? It's just underneath. So the area is going to be 3 times the average of my two heights, which are negative 7 and negative 1. 3 times negative 4. Bam. Negative 12. And let's just put a quick note here. This negative means below the x-axis. You know what? I don't like the way I wrote that. It just means below the x-axis, right? Shall we do another one? Now they're going to get interesting. Ready? Still negative x squared plus 3x plus c. Evaluated from 4 to negative 1. So that means that it's going to be f of 4 minus f of negative 1. Since we had a little bit of trouble with that last time, let's write that out again. So it's going to be negative 4 squared plus 3 times 4 minus negative 1 squared plus 3 times negative 1. All right. Negative 4 squared is negative 16 plus 12, negative 4. Negative 1 minus 3 is negative 4. Minus negative 4 is plus 4.
Why did you do 4?
Wait.
We got 0.
Wait, but I have a question. Why did you do the 4 first?
Because you always do the top number minus the bottom number.
But if it's A
Not
and
infinite.
B,
Close.
if it's A first and B first,
But we'll get there. There's a property. We'll get there, okay?
but it's always B minus A.
All right, let's do this. So we're going from negative 1 to 4. So I've got all this part up here.
Cancels out.
They cancel out.
They're exactly the same. Okay? They're just triangles, and they're exactly the same. It's base times height divided by 2 for each of them, and we end up with the same thing on the top and bottom.
Because they cancel out.
So, Mr.
It's all foggy though. I don't know why it's all foggy. But see, you're in the camera.
Can you explain to me?
Which
I
part?
think it's because the camera is trying to blur your back.
And it's blurring myself.
That blurs my hand too. I don't know. Anyway,
Teacher, can you explain to me why there are two triangles?
here,
the
because
area
we're going
of
the area here. So the area of this one. Let's do it in blue. Sorry. So the area of the first triangle here is going to be base, which is 2.5 or 5 halves, times the height, which is 5, over 2. So in other words, it's going to be 25 over 4.
That's the area.
That's the area of that one. And then the area of the one underneath is going to be 2.5, so 5 halves for the base. And then our height this time is going to be negative 5 halves. So we get negative 25 fourths. And when I put those together, it's 0. Yep.
Essentially, when you're drawing the triangles, you get in the interval, right? And you draw a line up so it can connect with the thing. And same thing here. Okay.
Yep, that's it. Amazing. Okay. Next one. We're going to go from negative 1 to 3. So this time it's not going to be 0, right? It's going to, what do you think? Is it going to be positive or negative?
Positive.
Positive, but we're going to lose some of it from the negative portion. So this is still going to be negative x squared plus 3x plus c. Now we evaluate from 3 to negative 1. So f of 3 minus f of negative 1.
So it's always the greatest minus.
Always. There's a case where it's not, and I'll show you properties of how to manipulate that later. Okay, but for now, yes, it will always be that way. Okay, so negative 3 squared plus 3 times 3 minus negative 1 squared plus 3 times negative 1. Negative 3 squared, negative 9. Plus 9, 0. Uh-oh. And then negative 1 minus 3 is negative 4 minus negative 4 plus 4. All right, I'll do it in more steps for you. Minus negative 1 minus 3 minus negative 4 plus 4. Does that make sense now? All right. All right, now let's draw it out. So we're going here. And we're going up to 3. So there's 2 ways to think about this. One of them is that I could just take this little triangle and kind of map it out onto here and realize that that's the part that cancels. Or I could do like the top shape minus the bottom shape. It doesn't matter. Let's do this. Well, we already know this top one here is what? The area of that blue one was 25 over 4. We did it in the last one. Now the one that's underneath is a little bit less this time. So it's going to be 3 halves times our height of negative 3 over 2, which gives us negative 9 over 4.
So we need to calculate both areas, or what? So
Yep.
So why did we do that first thing?
Because that's the area it is. We don't have to. I'm just showing you it's the same. Normally, you're not going to bother doing the areas. I'm just showing you right now that they mean the same thing. So I get 25 fourths minus 9 fourths, which is 16 fourths, which is 4. Exactly what we got. Okay? Now, here's the thing, you guys. Right now, these are about the same, right? Like, it's not that hard to find the area. It's not that hard to do it with the equation, the fundamental theorem of calculus. What if I have a curve? All right, it cut off real quick there, but it is negative 6. All right, next one. Last one. Nope, not last one. Next one. Okay. This is going to be 1/2 of f of x plus 2 times f prime of x evaluated from 3 to negative 3. So, 1/2 times f of 3 minus 1/2 of f of negative 3 plus 2 times f prime of 3 minus 2 times f prime of negative 3. And then I got to go look those up. F of 3. 1. So 1/2 times 1 minus f of negative 3, I believe, was 4. Plus 2 times f prime of 3 is 3. And f prime of negative 3 is negative 2. Then we just work all that out. You can't do that, however. So 1/2 minus 2 plus 6 plus 4, 10, 8, 8.5. What is the equation of the tangent line to the graph at x equals 3? Well, I need my pot, which is 3 and when x is 3, 1. And my SOT, which means that now I need f prime of 3. F prime of 3 is 3. So, y minus 1 equals 3x minus 3. Done. Use the equation of the tangent line in 5 to approximate the value of 3.1. Is it an over or under approximation? Give a reason. So, y minus 1 equals 3, 3.1 minus 3. Y minus 1 equals 3 times 0.1. Y minus 1 equals 0.3. Add 1. Y equals 1.3. Now, the second derivative at 3 is negative 3, so it is less than 0. Therefore, this thing is concave down, which means our tangent line would look like this, which means that it is an over approximation. And that's that. All right, so we crashed, so I turned off the camera to see if it's better. On the last one here, we're going to go from 5 to 0. You guys are all trying it, so I'm just going to do it. Well, yeah. Okay, it is. Close. F of 5 minus f of 0. So I'm going to get negative 5 squared plus 3 times 5 minus negative 0 squared plus 3 times 0. Negative 25 plus 15 minus 0. Negative 10. Do you guys want me to go through the area again, or are you getting the idea?
But do we need to know the areas or not?
The reason you need to know the areas is because sometimes we'll give you like a picture or something and not give you the whole equation, or like, so there's a few cases where you might need to, but no, usually you don't need to worry about it.
But then we just find the area of the big one, the area of the small one, subtract them, and we get the same thing. Okay.
All right, did everybody get that answer?
Yes.
Amazing.
When are we doing the curve?
Later. We'll get there, don't worry.
Do we have time or not?
Literally the next questions. All right, based on the results of the 5 previous examples, what inferences can we make about the value of the definite integral and the amount of the area bounded by the graph of the integrand and the x-axis? I just read this. All right, there's a few things. Ready? So, if we had the integral from a to b of fx dx, and it is equal... this is kind of awkward. I think it's easier if I type it. The area of the region bounded by f of x and the x-axis. Okay. What about if we have the integral from a to b of fx dx, and it is greater than 0? Well, that would mean the region above the x-axis is larger than the area below, right? Another case that we could have, integral from a to b, it could be less than 0. What would that mean? If it was less than 0, the area below is greater. So the region below the x-axis is greater than the area above. And the last case that we had was when they were equal, right? So when it was, sorry, when it was equal to 0, I should say. So the integral from a to b.
Wait, but that just makes sense. Wait, that makes sense just because it's just like where the function is located, right? Like where
Hang
the-
on, I can't hear you. Above and below are equal. I know, I should have given you more space. Is that what you're upset about? Well, I'm sorry that I did not give you more space.
But this just makes a lot of like just
All right, so for each of the following definite integrals, applying the fundamental theorem of calculus, show your work. Use your graphing calculator to verify the results. So in this particular case, this would become x squared minus x cubed over 3 plus c. And we're going to evaluate from 2 to -1. Ladies, come on. So this is going to be 2 squared minus 2 cubed over 3 minus -1 squared minus -1 cubed over 3. So that's going to be 4 minus 8/3 minus negative or +1 plus 1/3. 1 plus 1/3. All right, so that means that this is going to be, let's see, that'd be 12. So this will be 4/3 minus 4/3. It equals 0.
so the areas above and below are equal.
Yep, area above and below is equal. All right. Guys, what's the issue here? Who can see it?
Are we going to
It's not a
negative?
It's a negative power.
So if I drew out,
So why is there an issue?
why can't I?
It's x to the -2.
All right, so if we integrated this, what would it be? This is x to the -2
You divide by
plus x. Where is this thing undefined?
-2.
Negative 1 over x.
Wait,
Okay, let me get rid of that part that I wrote. Where is this undefined?
0.
Can I integrate if it's not defined at 0? And that's on our interval?
no.
Cannot integrate.
You just put cannot integrate and that's it.
Pero, Mister, you cannot integrate because it's between the interval, the 0, or because
Over a vertical asymptote. I can't integrate over a vertical asymptote.
How do you know it's a vertical?
Because 1 divided by 0 is a vertical asymptote.
are you dividing by 0?
Well, because my interval is from -2 to 3. The thing that would make that undefined is 0, and 0 is on my interval. Can't do it. Amazing, right? All right, for this next one, we're going to rewrite this first as the integral from 1 to 4 of 2 over x, so 2x to the -1, plus 3x to the -2.
So how did you do that again?
So remember, when I have something that's written with a common denominator, I can split it into both being over that x squared alone. Ladies and gentlemen, guys, if you're going to come in late, stop talking. Okay?
Why would it be -1
You heard
plus
me.
1? It needs
Ladies,
0.
you too. So I write it as 2x over x squared, which is the same as 2x to the -1. Then I write it as 3 over x squared, which is the same as 3x to the -2. Because it's, remember, when we first did derivatives, we had to do the same thing. You can't integrate a quotient rule yet. So we have to do this.
No, but then, Mister,
So then
Yeah.
0 would be on the bottom.
Pero no porque el
But it's zero's not a problem this time. Why?
porque no está en el-
It's not in the interval.
I said it.
Yes, you did.
So there, if we add 1 to the exponent, it's going to be 0. Then the integral is going to be 0 too.
What?
We have to add 1 to the exponent,
Yes.
and it's going to be x to the power of 0. So it's 1. So it's just 2.
No.
Mister, that's what I'm talking about.
It's 2 ln x. Remember?
Ah,
Remember?
So when do you do that, Mr.?
why? Why is it that way?
Anytime you just have 1 over x, it becomes ln of x.
1 over x. 1 over x.
Plus c. Now, ladies, I am going to kick you out. Ariana, thank you. Rather than going plus 3 over -1, let's just move the negative out here so that it's easier for us to deal with. Okay?
So minus.
Now let's find it. So it's going to be 2 ln of 4 minus, sorry, 3 over 4 minus 2 ln of 1 minus 3 over 1.
What is that number that you can do the log?
1. Well, 0. So 2 ln 4.
But 3 over 1, we don't do that. Just minus 3.
All right, I think I'm going to be done explaining, and I'm just going to do this now because you guys drive me all crazy again. That'll be 12 over 4, which would be 9 over 4.
And you can't simplify the log because you don't have a calculator.
No, I would just leave it like that. Next one, going to integrate.
Oh my god.
Don't worry about it, it's not that scary. It's going to be x squared
Is it undefined?
Sine x.
negative.
No, positive.
Yes. Good.
You're right, sorry. Positive. Positive sine of x. I wrote negative negative, so I think I knew it was positive. Plus c and evaluate it from pi to 0. So pi squared plus sine of pi.
I have a good question. Why do you keep writing this? It always cancels, or it was just
Because the integral is still technically with a c. But once I evaluate it, it won't matter.
it always.
Plus sine of 0, Ariana. Pi squared. What's sine of pi?
Negative 0.
Just 0. Minus 0 squared is 0.
1.
Plus sine of 0 is
0.
0.
Oh yeah, got it. Right.
So this is just going to be pi squared. All right. You think I know it says break, but let's try to finish it because we have virtual days and it would be easier if we finish it. Ariana, for the love of God, leave the room and come back. Seriously, go. Dear, go for a while. Okay, take her hand with you. Take her hand and go for a while. Pictured below is a table of values. So, same as always, we end up going to the tables because then we got to understand it better, right? What is the value of 1 to negative 3 of f prime of x? Well, that's just going to be f of 1 minus f of negative 3, correct? Great. So if I'm starting at f prime, I'm going to go back to f. Okay? F of 1 is negative 2. And negative 3 is 4.
Why negative 2? Wait.
Look. Don't panic. Look. We're just looking it up in the chart. What is f of 1? F of 1 is,
Wait, did you say
which is,
one?
remember I told you that means the one before. If this is f prime, then this is f. Okay?
Wait, what?
Guys, the reason you never understand is because you don't listen to me explain it. You yell over each other, and then you're like, what?
Okay, but
Just,
maybe
no.
because we have to
Just
to the
listen.
right at the
Yes,
same
yes.
time.
But listen to me when you ask a question rather than like yelling at each other and answering each other's questions. It'll save you time, trust me. Go.
Again.
F of 1, I go to here, f of x. Why? Because I took the integral of f prime, which would be f. I go to 1, it's negative 2. Then I subtract it when it is at 3, or negative 3, sorry. So f of x of negative 3 is 4. Negative 2 minus 4 is negative 6. Okay, next one.
That's
Now, we do this one. Oof, are you ready? What would the integral be first of all? It's going to be f of x plus f prime of x evaluated from 3 to negative 1. So that means it's going to be like f of 3 minus f of negative 1 plus f prime of 3 minus f prime of negative 1. Does that make sense?
I've stopped understanding.
But why f of 3 minus f of 1 and not f of 3 plus f of 1?
Why are we doing this?
Because it's always minus. Like every single time we've done this, it is minus.
The equation is f prime of x plus.
That's why I wrote plus. The plus is still there.
Ah, okay, it's just switching.
I have, guys, when I'm doing the f of 3 and f of negative 1, I have to subtract them, same as we've done for the fundamental theorem every single time. If it makes it easier, think of this as being two separate integrals. The integral of this one plus the integral from negative 1 to 3 of f double prime. Think of them as separate if it helps. All right, f of 3, when I go look at my chart, is going to be 1. F of negative 1
0.
is 0. So minus 0.
F prime.
Hang on. Yeah. I'm feeling like I did that wrong now. Hang on. F prime of 3. Let's just do it for now and then I'll take a look at it. 3 minus f prime of negative 1 is 1. All right. So 1 plus 3 minus 3. 3. Basically, the two ones can just cancel if it. No, I did it right. I was good. I did, yeah. I had a momentary relapse of like, oh my god. All right. Can we do it? Can we do it? Let's do it. Now we can do the last one. Ready? This one's going to be 3f prime of x evaluated from 5 to 1, which means it's going to be 3 of f prime of 5 minus 3 of f prime of 1. F prime of 5 is 2. 3 times 2. And f prime of 1 is going to be 0.